Hey, welcome back everybody to part two of transformations of log functions. Okay, so how did that final graph go? We have log base 3 of x minus 2. That minus 2 is not inside the log because only if there were brackets around it, like there was on double I here, would x minus 2 be all inside the log, which means x was replaced with x minus 2 here. But here, that minus 2 is actually a vertical translation, and that would be down 2. So if you take all of your points from the original log base 3 graph and move them down 2, we should get this purple graph showing up here. Okay? Now, let's do part B. Do any of the above transformations result in a change in the original domain or range? Let's talk about range first. You'll notice all of these graphs go forever down, see these arrows heading down, and forever up. Granted, less steep, but they are still going up. So as a result, y is an element of the reals for all of those graphs. So no change in the range. No change in the range. It rhymes. Okay, so no change in the range. But domain, however, let's look at that. Okay, so for the original graph, the domain was x greater than 0. Okay, and that was true for the first graph because we did a vertical stretch, so that didn't change the domain. The second graph, though, that moved right 2, our asymptote moved to the right 2 as well. So therefore, our domain became x is greater than 2. So when we moved it to the right 2, we had a change in the domain. When we moved it down 2, though, this kind of pinky purple graph, looks like it's still x greater than 0. So do any of the above transformations? Yes. The translation of right 2 changed the domain. All right, state the equation of the asymptote for each part A. So for the first graph, we'll just write it here, our vertical asymptote for the first one would have been x equals 0 because it was only a vertical stretch. This one, when it moved right 2, our new asymptote became x equals 2. And for the third graph, it was basically didn't move left or right, so it still was x equals 0. Okay, so in other words, the asymptote was affected by the right 2 as well. Okay, let's look at the next page. Okay, next page we're going to look at a little investigation, which is kind of interesting. We know from our power law that log base x of n is the same as, if we move that exponent down front, is the same as n log x, right? But the question is, are the graphs identical? Okay, so what we're going to do is we're going to bring up the calculator and we're going to take a look at that. And we're going to try both odd and even values for n. So we're first going to try, say, if n is equal to 2, and we're going to look if y equals log of x squared is the same as y equals, so we're going to put that in y2 and this in y1, of 2 log x. Okay, so let's grab our graphing calculators and graph each of those in y1, y2, and take a look at the graphs. And you want to go zoom standard probably to look at the graphs. Okay. Okay, so in your graphing calculator, you entered y1 equals log of x squared and y2 equals 2 log x. Okay, in theory, these should be the same, but let's take a look at the graph. I'm going to go zoom standard, number 6. Okay. Oh, you know what we should do? Let's make the one of these graphs a bold line so we can see if they're the same or not. Okay. Let's go and make y2 bold. There we go. By going over that little symbol and then hitting enter. Okay. Now let's look at the graph. Oh, okay. What do you notice? We have the original y1 graph is basically this part here and that part, but the y2 graph, the bold part, is only the right-hand side of that graph. Huh, I wonder why that is. Let's try it for n equals 3. Okay, so once again, we're going to do this. And so this one basically looked like this. That was y1. And then y2 looked like this. Okay, so y2 and y1. Where's that pretty pink purple? This was y1. Okay, now let's try it for n equals 3. So we'd be graphing in y1 log of x cubed, and in y2 3 log x. All right, so put that in your graphic calculator. Let's take a look. Okay, so we go exponent 3 now, and a 3 in front of here. All right, let's look at the graph. Oh, okay. So if you saw that graph, they are now identical graphs in this case. So let's think about that. So these ones are identical, okay, and they both looked like that and like that. I wonder if I'm drawing those right. Let's take a look at that graph again a minute. Oh, sorry. I'm having them start here, but they actually look like, that's what I get when I don't look at the graph close enough. They're going like that, right? Okay, and for these ones, same thing. It's going like that. And here, this went down like that. That went down like that. Okay, anyways, the point being how the graphs look on top of each other. So these ones are identical, those ones are not. Let's think about that. If you recall, we can't log 0 or a negative number, right? So what's happening here is with the x squared inside the log is the value of x is actually getting squared first and then finding the log of that value. So all these negative x values like -4, if I put that in for x, it'd be -4 squared and then it became positive 16 and there's no problem then with finding the log of that. Whereas here, x is what it is, and therefore we can't really go into 0 or negative values. These two, when the exponent is odd, if x is negative, we end up with a negative value, so we can't have any values left of 0. Okay, so interesting little thing, and now we should be ready to do the assignment. We're not doing all of the assignment because some of it is out of our bounds that we're going to work on. But good luck with that. And then after this, we'll work on some equations and some applications from the next chapter in your workbook. Okay, have a good day, you guys.